Welcome to Econ 317. In this instruction video, we will go over the concept of the elasticity of demand, more precisely, own price elasticity of demand, as well as own price elasticity of supply. And we'll start with the simplest example where we'll assume the demand or the inverse demand functions to be linear. Same for supply. So let's start. Own price elasticity of demand. First, the notation epsilon. This is the Greek letter which looks similar to E, but this is epsilon. And I will write down the formula for the own price elasticity of demand. It is 1 over slope of the inverse demand function. That goes into the denominator. So this is first term multiplied by, choose a combination of price and quantity which lies on the given inverse demand function. So we begin with the case where we have been specified the inverse demand function. Which is price on the left hand side, price as a function of quantity. So let's say this is given as 100 minus 4 times Q. I will draw this inverse demand function. We should always have this habit of being able to draw the graphs wherever feasible. So if you look at this inverse demand function, when Q is 0, price would turn out to be 100. So that's the vertical intercept. And then we can find out the horizontal intercept. When price turns out to be close to 0, the maximum quantity we can observe is 100 over 4, 25. So you can see the slope is the rise over run. So 100 over 25, but with negative sign. Turns out to be negative 4. So first time I know, and now let's look at some values of elasticity. So for Q to be 10, let's see what is the elasticity. First we know if Q is 10, then price is 100 minus 4Q, 100 minus 4 times 10, 40, so turns out to be 60. So the elasticity is 1 over the slope of the inverse demand, no negative 4 times price 60, quantity 10, so minus 60 over 40 minus, I can divide both numerator and denominator by 20, that is factoring out 20. So I'll get minus 3 over 2, negative 1.5. Let me add another piece of information. For elasticity to be less than negative 1, we say the demand is elastic at Q, at the given Q and P. So here Q was 10, P was 60. Okay, I will do a pair of additional computations. So now let's take quantity to be 12.5. Then price is 100 minus 4 times 12.5. 100 minus 50 turns out to be 50. Okay, very good. With that, I can again compute my elasticity. 1 over the slope of the inverse demand, no change, always negative 4 times P 50, Q 12.5, and now you can see this is minus 50 over 4 times 12.5 is 50, so negative 1. We say the demand is unit elastic at the price quantity combination when the elasticity turns out to be negative 1. Okay, that was the second, and I said I will do one more. So now let's take Q to be 20. Then P is 100 minus 4 times 20, which is 100 minus 80, turns out to be 20, and I can compute the elasticity this time as 1 over negative 4, that was the slope, times P 20, Q 20. So this turns out to be, these 20 and 20 cancel out, negative 1/4, negative 0.25. And this time we will say the demand is inelastic if the elasticity turns out to be greater than negative 1, which is the case here. It is negative 0.25, so demand is inelastic at the price quantity combination. So at Q20, P equal to 20. Maybe now I can go back to the demand and show these observations in the graph. So Q here, P here. Remember the graph of the inverse demand was 100 vertical intercept, 25 horizontal intercept. I want to first draw the midpoint, which was 12.5. So 0 and 25, the midpoint is 12.5. You can check the price for the quantity 12.5, 50 is also the midpoint of 0 and 100. And here we had seen elasticity is negative 1, unit elastic. When I took the quantity to be 10, we saw the elasticity here was, so let me first point out this price quantity combination with 10, I have price to be 60, elasticity was negative 1.5, we call it elastic demand. So this was unit elastic demand. And now I go to the other extreme where we had taken the quantity to be 20. In this situation, the price also turned out to be 20, and we got elasticity to be negative 0.25. We call it inelastic demand. For the linear case, this will always be the case that at the midpoint demand is unit elastic. To the left of the midpoint demand is elastic, and to the right of the midpoint demand is inelastic. So for linear inverse demand, at the midpoint elasticity will always be negative 1, unit elastic. to the left of the midpoint, elasticity will always be less than -1, which is elastic. To the right of the midpoint, elasticity will always be greater than -1, so inelastic. So this is unit elastic, elastic, and this is inelastic. So this example, we were given the inverse demand function and we did the computations. It could also be the case that we have demand function instead of inverse demand function. And I want to apply the formula. So let me write down the demand function. It is given as Q equal to 20 minus 2P. Remember, in the formula, I have to find out the slope of the inverse demand function. So let's make the transformation such that we have P on the left hand side and Q on the right. So I move this negative 2P from right to the left, turns out as plus positive 2P plus Q equal to 20. But then I need Q to be on the right hand side. So 2P is 20 minus Q. The sign changes as the term moves from the left to the right. But then I need P by itself rather than 2P. So I will divide each term on both sides by 2. So I get 2P over 2 equal to 20 over 2 Q over 2. So I have P equal to 10 minus 0.5 Q. So this is the inverse demand. And now we can find out the slope. So the slope of the inverse demand is negative 0.5. So let me choose a price quantity combination to figure out the elasticity of demand value for the given price. So let's take P to be 3. Then I know Q is 20 minus 2P, 20 minus 2 times 3, which is 20 minus 6, 14. Now I have all the information. I can compute the own price elasticity of demand 1 over the slope of the inverse demand function 0.5 times P, which is 3, Q, which is 14. I can simplify. Half times 14 is 7, so I have negative 3 over 7. And you can see this is a number greater than -1. So I can say demand is inelastic. The third part is where we want to look at the own price elasticity of supply. So own price elasticity of supply. And again, it is the same formula. So epsilon, this time for supply, 1 over slope of inverse supply function times P over Q. So formula remains same. The only difference is now we have look at the supply function. So I will give an example of one set of computation. So let's say price is given by 5 plus 2Q. So again, I will start with first drawing the graph. I have Q on the horizontal, P on the vertical, and the vertical intercept is 5, slope is positive 2, so upward sloping supply, the slope is 2. I like to compute the elasticity when when the quantity is given to be 5. So take Q to be 5. Let's see how we compute the elasticity. When Q is 5, then P is 5 plus 2 times 5. 2 times 5 is 10, so I get 15. And the slope we have already seen of the inverse supply function is plus 2. So now I am ready to compute the elasticity. 1 over 2 times price 15, quantity 5. So 15 over 10, 2 times 5 is 10, 1.5. Remember, the own price elasticity of supply is always positive. As we had seen earlier, the own price elasticity of demand is always negative. Let me take another computation. So Q to be 10, price will be 5 plus 2 times 10, turns out to be 25, and the own price elasticity of supply 1 over 2. 2 is the slope of inverse supply times P 25, Q 10. So I got 25 in the numerator, 20 in the denominator. This is 5 over 4. By cancelling out 5 from both numerator and denominator, 1.25. And this is a good point to stop.